All right, so let's get started. So the first couple questions are just demographic questions to kind of get an idea of what you do and how you use agent-based modeling. So do you work for an organization that specializes in agent-based modeling? And if not, what does your organization specialize in?
Yeah, so I'm working for Lucidminds, which is a startup in Amsterdam, and indeed we specialize in agent-based modeling, but also data science more generally. So AI-related themes, machine learning, and all that.
Okay. And what is your specific title?
So I am head of simulation at Lucidminds.
Okay. So what is your role in the agent-based modeling process?
So to start off with, since we're a startup, basically everybody has to do everything, right? So we're only 3 people at the moment. So my main role as head of simulation, first of all, is to attract clients and projects to basically offer our agent-based modeling services. And then, of course, if we get some projects, to execute those projects, so to also do some project management and maybe even do some coding myself if we don't have a big budget or so, but otherwise also
Interesting.
hiring people.
Gotcha. So a little bit of everything. So how much experience total would you say that you have in agent-based modeling?
So I have kind of in the university, I think I got to hear about agent-based modeling in 1998, so 22 years ago. And I did a PhD that was kind of combining ABM with economic theory and nonlinear economic dynamics. So that was like 2000. I did some European projects, so macroeconomic modeling. I did some consultancy for the ECB, European Central Bank. And I taught courses in university, so for master and PhD level. So I also have some teaching experience in ABM. Yeah, and now I'm doing a startup with some close colleagues.
Wow, so you've been doing this for a long time. I think you may have the most experience out of anyone I've spoken to. So what does your organization typically use ABM modeling for?
So it's basically one of our main value propositions. So of course, we don't say that ABM is the solution, the one solution that fits all problems. That's not what we do. But if there is kind of a data science issue and there is some behavioral aspects, then we try to figure out if it is useful to do an ABM with the client. So it's basically, you can say it's a service that we do kind of for a client, or it's a product if we are delivering basically the software and sell it as a model. Yeah, so that's what Lucidminds is doing.
Gotcha. So what do your customers typically want out of an agent-based model? What is their purpose for getting one made?
So currently, we're looking into issues related to collective climate action. So it is about all the issues in Europe around energy transformation, circular economy, these kinds of themes. So currently, we're mostly interested in projects or clients that are in this area. So companies or NGOs or partners and universities that are interested in doing something that is combining climate with economic modeling, some sociological aspects. So there has to be a behavioral aspect, of course, to make it sensible for there to be an ABM. Yeah, I would keep it at that.
Okay. And what ABM tools do you guys normally use?
So what we try to do is use best practices from agile methodologies. So before we start to implement any models, we first try to kind of do like a participatory session with the client or with project partners to kind of first analyze the problem before we do any modeling as such. So first kind of get modeling requirements as a first step. Then the next step would be kind of to make an infrastructure of the ABM. So if it is an ABM, if you find out it's not supposed to be, then not. Then we do some other data science. But so if we do an ABM, then of course we need to first lay out the design of the infrastructure. So not any behavioral methods. And then we are basically using UML diagrams, some state diagrams for kind of finite state machines. And if that is kind of all well connected as kind of infrastructure for the model, then we are implementing actual functions. And there as tools or as framework, I mean, one of the things that we are very, very familiar with in Lucidminds is Flame. So that's the flexible, large-scale, agents-based modeling environments. But I mean, depending on the features that you would need, we could also use another platform. Depends a bit on kind of how specific, if there's some geographical information that has to be included, or if there's some network structure that has to be there, then different platforms have different strong sides that you would rather use. And so there you can switch a bit back and forth, but that's kind of how we would do a project.
Okay, so you said the Flame environment is like your primary platform though?
Yeah, that's the one that we are most familiar with, also within the team. So we have a couple of people who also did PhDs in ABM work. And but I mean, in general, I mean, it's very easy to switch, you know. I mean, you have some platforms in Python, you have some platforms in Java, you have some platforms in C or C++. And the features are all kind of similar, how you you create objects or agents or some subclasses. And yeah, so we basically look at what platform would fit best for a particular use case.
Gotcha. Okay. So moving on a little bit, what impact have you noticed that agent-based modeling has in the decision-making process?
In the decision-making process of politicians?
So for example, is it like when in the decision-making process, do they use it to like validate expected results? Do they use it to test different scenarios? How do your customers normally implement it into their process?
Well, so the projects I've worked on previously before Lucidminds were mostly academic projects. So the proposal is to offer a model that is a decision support system. So that would be, in fact, it would not be a prediction type model, right? It would be more an explanation type model to search for mechanisms that explain a certain phenomenon. So in that sense, for decision making, you would have an assisting tool. So it's kind of a decision support tool. And then usually the way you would use an ABM is to run different scenarios where kind of you have a baseline scenario and you have a counterfactual scenario, multiple counterfactuals, and those can be just changes in one mechanism. So you would just have a switch from 0 to 1. Or you would have a parameter which is a continuous parameter for some behavior rule, perhaps, to just see what happens if you change behavior of people or of institutions. Or it would be like a policy parameter where the policy institution, like the ECB, for example, could change a parameter in a rule. So say the interest rate or some other rule that would have an effect on the model's behavior.
Okay, gotcha. So you said that you typically work in like collective climate action. Have you ever modeled, for example, like a natural disaster or something like that, and modeled like a disaster recovery?
Well, the disaster recovery, well, the climate crisis is like a disaster that is not yet finished, right? So you could say if you make an ABM that will help to take action collectively to mitigate or to adapt. I mean, it's about adaptation strategies as well, not only mitigation strategies. For climate or for energy transition, then I would say yes, that's a disaster recovery. But I think you mean something more like just quick disasters, right? Like emergencies, like
Yeah,
9/11
exactly.
type, this type of work. No, this type of work not. No, I know that there is a lot of work going on evacuation modeling,
Mhm.
hospital evacuations, city evacuations, crowd simulations. All these things apply to that. We have not been involved on that as of yet. No.
Gotcha. Okay. Um, Switching it up a little bit, how is data typically gathered for your models?
So that of course depends on what kind of project you have. If you have a very data intensive project, or if you work with a client who has data itself, so in the economic sphere, when working with the ECB, for example, you usually have a lot of administrative data. And so there's official data collected by any institution, so statistical officers, the ECB itself, OECD. So that would be administrative data. Another source would be survey data. So there are also, again, publicly available survey data, which are free or for a price. So sometimes you have to pay and then you put it in the budget, of course. And then, well, you could collect data yourself, but we have up till now not, as Lucidminds, not done this collection of data ourselves. Due to the fact that Lucidminds also has an orientation towards transparency and data ethics. We are very much into this democratization and openness of algorithms and data. Although one thing comes to mind, we did do like a trial project about the US elections, which was based on Twitter feeds. So there was like a tool which is around the US presidential elections, where you can enter your own Twitter handle, and then the tool will basically download or extract your Twitter data, your texts, your tweets, and will analyze it based on 10 human values. So it will classify your tweets in basis of values from Schwartz. So those are things like orientation towards openness, your political kind of, if you're a liberal or conservative, this kind of things you can extract from those kind of text tweets. And then the tool will compare it to one of the candidates. So you could compare yourself. When there was all the Democratic candidates, we had like 20 comparisons you could make. So that was one tool that was kind of a trial tool of Lucidminds. And yeah, so that was based on tweets. So that was just the API of Twitter that was just used to, with allowance of the user, to extract that data.
Wow, that's really interesting. That's a really cool application of it. Okay, so it's very situation specific then, the way that you go about collecting the data. There's no like one size fits all general approach. Okay.
It depends if you work with policymakers or with more private oriented clients, or with the general public, right? If you have the general public in mind, then you have such sources with, yeah.
Okay.
User supplied data, you could say.
Gotcha. So once the model is complete, do you guys have like a standardized approach that you take to validating model results, or is that also situation specific?
Well, that's a good question. Of course, validation of model results is a very important topic. So there are so many different sizes of ABMs, right? I mean, you can make an ABM of, say, a factory of one firm. I mean, you can make a digital twin and they call it an ABM. It's kind of very close together, of course. Or you can have a macroeconomic ABM, like basically I have been involved in. And those are different purposes. So also the validation is very different. What is important in both those cases is just empirical data, real world data to compare your output to. But not only the output is important, also the input verification, of course, that first the input data has to be somehow sensible empirically. And I mean, there you can do all kinds of gradations, right? You can just look at the distributions, probability distributions, or you can actually input individuals from a survey one-to-one to an agent, that would be input validation. And then you are more close to what is a micro simulation, because then you are inputting basically a micro simulation database or micro economic database into your ABM. So that's also a form of validation. So it's not only in the output side, it's also on the input side, I would say.
Okay. Based on your experience, what would you say are the most important factors for the success and accuracy of a model?
So factors for the success of a model, so you could say, are there metrics, right, or criteria on which you can say that the model is successful? So I would say, first of all, if it's accepted by the stakeholders. So if you are making a model and then it's rejected by the people who pay you, that's not a good sign. The other one is, of course, if other people start to imitate you or start to basically take your ideas and re-implement them in another model, that's a good sign of success. Then, of course, you have the more mundane types of metrics of just predictive accuracy, say. I don't know if that's what you also mean, but so success in terms of whether a model is fit to the purpose that it was made for, right? Fit to purpose is one of the criteria for validation, but also for success, of course. So whether model, of course, you can say, are the predictions okay? Similarly, for an economic model, you can say, is it making predictions that are somehow in the ballpark of its range of confidence? So is the empirical outcome in the range of confidence of the model? Because the model doesn't give you a point prediction, right? A model, at least I think it should. A model should always give you a bound of errors, like a confidence interval.
Right.
So that would be a very quantitative metric of success, of course, if the empirical outcomes is in this interval of your model. And then it's better if your model is tighter, of course, if it makes more accurate predictions. And then if it turns out to be correct and accurate, then it's, of course, a success, I would say.
Okay. Interesting. So you mentioned at one point the model being accepted by the stakeholders. How do you find that models are typically received once you present it? Is there much support for it? Is there, people who don't quite understand or believe that an agent-based model is useful?
Yeah. So the biggest issue you run into when you are working directly with stakeholders from the start is to understand what is actually the problem that they're trying to solve. And then if you make a model, of course, the selling point is whether the stakeholder is agreeing with you that you've solved their problem in that way with that model. And the problem might be that from the beginning, the stakeholder was thinking that you would provide them with a crystal ball, which of course we are not able to. So in the beginning, one of the very important things when communicating about a project is clear expectations management, right? So to get a model accepted by a stakeholder, it has to be clear from the beginning is what can a model do for that stakeholder. So that of course depends on the complexity of the problem they are presenting. Take the climate action problem. There are so many stakeholders with climate and so many trade-offs, so many counter opposite beliefs about not only about that it's really a problem, but it's a so-called wicked problem, right? It's a problem that does not have a clear solution. And so then you cannot satisfy all stakeholders, that's clear, because they have opposite wishes, opposite preferences. But so at least if you have managed to kind of inform the stakeholder about the problem, that it's more clear already, that could be a reason for the stakeholder to accept your model.
Right. So I'm assuming as head of simulation, when you're speaking with clients, you're probably speaking directly with organizational leadership, right? Do you see that there's a disconnect by the way that it's received between an organization's leadership and perhaps like their engineers who are more familiar with data science and agent-based modeling?
So definitely there is a big gap between people who are just starting to get interested in all kinds of things related to data science and machine learning and ABMs and simulation. And of course, that's understandable because you cannot kind of become an expert in a short period. And then there's engineers, also in the agent-based modeling world, who might oversell some models, right? Or are very, very down to earth and say, well, I'm not sure if we can do it. So very kind of skeptical from the start because they know the problems with kind of getting a model to run. There are issues, of course, with data and data quality, which are kind of not a problem of a model, but they can become a problem of a model if you are in need of some micro data, very fine-grained data, and that data does not exist, of course, can be. I mean, you see it with the machine learning models, the deep learning models, that for some regions or some problems, there is not enough data. That can be an issue. So these things cannot be trained properly. And so then, of course, you see a big divide between kind of executive level knowledge and people on the ground who are implementing those type of models. I think that's the same for all data science and AI related methodologies, basically.
Okay. So when you're building a model, what are the factors that impact the cost of implementing that model?
The cost. So, okay, so you of course have direct costs and you have some hidden costs. So direct costs are of course personnel costs. It takes just a lot of time and you have to hire these people. Also, they have to be trained, of course, before, so they go through university. That's a cost. Then you have time as a cost, you could say. Hidden costs, that would be opportunity costs. You could have spent that time doing something else. Then you, of course, you directly have, after you've implemented the model, you have compute costs. So some models are quite large, or you want to keep them running. Say if you're a model of a factory and you want to do some predictive maintenance and you have some input of data continuously, then you would run that on a cloud system and you would have a computing cost that can go up quite quickly. I mean, the type of models I've worked with the ECB, if you there have a model of a macroeconomy, these are also typically things that are quite large. So you would need not a cloud-based, but more high-performance computing, so HPC. There you would have a cost. Then, of course, you have kind of what is called code debt, right? Technological debt. By having code that is maybe not properly maintained, right? So you have some costs there, so more abstract costs, but still there are costs. I think in general for agent-based models, the same things hold as for any software development project, basically. The human costs, the technological costs.
Okay. Okay, yeah, that makes sense. So do you ever, have you kind of, as you've progressed through agent-based modeling, have you found ways to kind of mitigate those costs? Ways to work smarter in some areas to reduce the costs of building a model, or maybe of, like you said, the infrastructure of housing a model?
Yeah, there are by now solutions, of course, in place that were not there in 2000, say. I mean, in the last, say, 5 years, there have been a number of companies who've started, of course, around ABM, offering either modeling services or offering platforms. Then there are all these open source platform solutions. And so those have facilitated enormously these difficulties, these costs. I mean, if you now do a PhD and you do something with ABMs, you maybe have 10 different platforms to choose from. And then your cost is basically selecting which tool to use, rather than previously in 2000, you would have to write your own kind of agent-based platform, either from scratch in some programming language or in MATLAB or whatever object-oriented language you have at your disposal. So that's all kind of taken care of in a way. I mean, there can be improvements still made in those platforms. But then if you go to kind of the other side of computing models, There are also tons of platforms now where you can easily load models on some kind of containerized environment, and you can run them on the cloud, right? So it's easy to do large amounts of simulation, of course, again, with the cost of paying for that compute, but you don't have to, you have your own big computer, basically.
Okay, well, it's good to hear that the cost has been going down as the field has progressed.